So hello everyone, welcome to Coders Arcade. So today we are going to learn about graphs in DSA. Okay, to be specific, whatever graphs is required in data structures and algorithm. Okay, only that part of graphs we'll be doing, not the entire subject as graph theory. Okay, so here when we are talking about graph, so what is a graph? If we have to say it in a definition, then the proper definition for it is a graph is a collection of nodes or vertices and edges that connect all those nodes. Okay, and what are nodes here? The nodes in a graph, they represent various entities, and the edges that we have in a graph, they represent the relationship between those various entities that we have, or the various nodes that we have in the graph. Okay, so now if I would say that, can you tell me any real life implementation of graphs? Yes, we have a various number of real life implementations of graphs. Suppose the Google Maps that we are using right now, whatever the different places that we have, those different places they are different nodes, and whatever the roads we have, those roads are the different edges. Suppose if I have to go to Mysore from Bangalore, then there are multiple different routes. One route I have is through Ramnagara, Biddi and all. I have another route through Kanakpura. So from going from one node to another node, there are multiple different ways of going. Now whenever we are searching for that on a Google map, depending upon the time or the distance, it shows which is the best possible option. Then similarly on social media, whatever the social media platforms that we have in today's world, maybe Facebook, Instagram, Snapchat, LinkedIn, all those different type of social media platforms, they are using graphs to build the relation between various people. Suppose if I have four people, let's say A for Abhay, B for Bhavesh, C for Chandan, and D for Dinesh we have here. So here we can, if I see that A and B have a relation in between them, B and D have a relation, B and D and C have a relation here, and B and C also have a relation between them. But here A and C don't have a relation between them, and similarly B and D, they also don't have any relation between them. So in those type of cases, our social media platform would give us suggestions. B will be given a suggestion that you can be friends with D. D will be given suggestion that you can be friends with B. Similarly, A and C, they will also be given suggestions to become friends with C or A respectively, right? So these are the different implementations of graphs that we have. Now this is also just a simple graph that we can say. So now if we have to divide graphs, if we have to classify graphs into different types of graphs, then there are multiple ways of categorizing them. The first one we have is directed and undirected graph. Now the first one, directed graph, whenever there is a direction given on the edge from one node to the another node. Now let's just take example here. You can see that here we have a graph. Now is there any direction given on any of these edges? No, there is no direction given on any of the edges. If I look for the edge which is in between A and D, I can go from A to D, and also I can go from D to A. Both are possible here. So this is called as a undirected graph. Undirected. This is called as an undirected graph because the direction is not given here. Now suppose if I give a direction in this graph, this, and now as I have given some directions over here, that for A and D I can only go from A to D, I cannot go from D to A. Similarly for A and C I can go only from A to C but not from C to A. For D and C I can only go from D to C but not in the opposite direction, and similarly for A to B I cannot go from A to B but I can only traverse from B to A. So this is a directed graph because the directions are given that in which direction I can travel. I cannot travel in any other direction. I can travel in those directions in which it is directed. So this is the basic difference between directed and undirected graph. So now depending upon the weight given on the edges in a graph, we can figure out that it is a weighted graph or it is a unweighted graph. Suppose if I take the same example here, so now this graph is a simple undirected graph, we know this. But now, is there any weight given on any of these edges? No, there is no weight given on any of these edges. So whenever no weight is given, by default we are going to consider that the weight of all the edges is 1 here. If it is undirected, then 1 is the weight of all the edges. Now if I have to show you an example, and if I want to just make this graph as a weighted graph, so I will be giving some weights here. So these are the weights of all the different edges here. Now in the implementation of a program, these weights, this can represent anything. It can be distance from one place to another place. It can be the cost of travel. It can be anything depending upon the implementation. Why are we using it? Okay. So this has now become a weighted graph. So now if we just consider the previous one, it was directed and undirected, and now it is said as weighted and unweighted. And if we combine them, they will become here as directed and weighted, directed and unweighted, undirected and weighted, undirected and unweighted. Okay. So now this one, is there any direction? No. Is there any weights? Yes, there are weights. So now this has become a undirected weighted graph. If I give some directions over here, this, and this. So now this has become a directed weighted graph. If I remove all the weights now, so this will be a directed unweighted graph. So this is how the different classifications are done. So now here, if our graphs are undirected, no cycles are formed here. But if our graphs are directed, some cycles can also be formed here. Okay. So the graphs are also divided in another way of categorization as cyclic and acyclic graph. And they are only done whenever the graphs that we have, they are directed. If they are undirected, let's take this example. As we know that they can travel in any direction, so it is obvious that they will be forming cycles. So now we can classify them as cyclic and acyclic only when they are directed. So before this, what is a path right now? So what is a path? Path is a sequence of node when we are traversing through each node in a graph. And to be specific, no node should be repeated again and again, except the first node. The first node will be repeated again at the last. It will be written again at the last, but no other node which is in the middle has to be repeated again. Okay. So now if I take this example, so here it is forming a cyclic graph here. A to D, D to C, C to A again. A to D, D to C, and then C to A. We started from A and we again reached A here. It means it is forming a cycle here. So as it is forming a cycle, so this is called as a cyclic graph. Now the direction that we have here in between A and C, it is going from C to A. Now suppose if I change the direction and if I make it as A to C, so now in this case it will no longer be a cyclic graph because the cycle will not be forming here. So now if I see here, it can go from A to D, it can go from D to C, but it cannot go back to A from C. So now in this case it is no more forming a cyclic graph. This is called as a acyclic graph. In the previous case it was a cyclic, the path that we have written here, A to D, C, and then again back to A, but in this case it is not forming a cycle. It is not forming a cycle anymore. So this is a acyclic graph. Okay. So now next very important thing with the graph perspective is about degree. So what is a degree? Degree is nothing but it is a value of how many edges are coming inside a node or it is going out of a node. Okay. So now here if I take all the nodes. What are the different nodes that we have here? A, B, C and D. If I ask you what is the degree of all the nodes, we can see here that 3 edges are connected to the node A here. So the degree of node A is 3 here. Similarly, if I check with B, B has how many edges? B has only one edge, so the degree of B is 1. Then degree of C, we can see here that there are 2 edges, so degree of C here is 2 and degree of D is here again as 2. This is what we call as degree of an edge. Okay, and if we have to check that what are the total number of degrees, so the total number of degree here is equal to 8. Okay, now this is about undirected graph. Now if I say that if the graph is directed, so let's make this as a directed graph here. So here I have made it as a directed graph, right? So now in case of directed graph, instead of degree we have 2 terms which is replacing degree here. One is in degree and the other one is out degree. In degree means how many edges are coming inside the node, and out degree means how many edges are going outside the node. Okay, so here if we check with the first node A, how many edges are coming inside A? There is only one edge, that is from B, which is coming inside A. So the in degree here is 1, and the out degree, how many edges are going out? So total number of edges going out are 2 here. So the out degree here becomes as 2. If I check with the node B, inside the node B there is no edge coming inside B. So the in degree here is 0 and 1 is going out. So here it becomes 1. Similarly with C, how many edges are coming in? 2 edges are coming inside the node C. So the in degree is here is 2, and as no edges are going outside C, so the out degree here is 0. If we talk about the node D, one edge is coming in and one edge is going out. So D has an in degree of 1 and out degree of 1 here. Okay, so this is all about degree in case of undirected graph and in degree and out degree in case of directed graphs. Now coming back to the classification, we came across directed and undirected, weighted and unweighted, cyclic and acyclic. Now similarly we can combine and we can take all of them as together. We can say it as a weighted directed cyclic graph or weighted directed acyclic graph, unweighted directed cyclic graph and unweighted directed and acyclic graph. We can combine them together whenever and however it is required. Okay, if you ask me of any example for a difference for let's say weighted directed cyclic and weighted directed and acyclic. So now let's look here for an example. Okay, suppose here I have a graph, okay, with 4 nodes I have, and they are directed here. Okay, now what are the weights? 1, 7, 3 and 4. So now if I see, is any kind of cycle formed here? No cycle is formed here, but it is weighted and directed. So we will be naming it as a weighted, directed, and then it is a acyclic graph. So now here similarly, if I take these 4 edges and the direction are given as such, and the weights are same here, 1, 7, 3 and 4. So here we can see a cycle is formed here, right? So this one here now becomes as weighted, directed, and also it is a cyclic graph. So these are the different classifications how we can define them. It is not that we have only 1 or 2 kind of different graphs. Any different kind of graphs can be formed here. Okay, so this is just the basic knowledge about graphs that everyone should know before starting with proper graphs that we are going to learn in data structures. So please go through this video before starting with the other videos. If you have not understood anything, then please watch the video again, and if you have any doubts, then please give us a comment in the comment section. We will definitely get back to you. And if you have liked the video, please press the like button, because that gives us a motivation to record a new video every time. If you have not subscribed to our channel, subscribe to our channel, and don't forget to press the bell icon so that you get a notification whenever we are uploading a new video. So thank you very much. Keep learning.